Today we want to start looking at angles. This is the main thing that we're going to be looking at in trigonometry. It's one of the big parts of the triangles. I mean, it's right there in the name, triangles. So we need to talk about how we're going to measure angles and how we're going to name angles. So an angle is just the space in between two intersecting segments. So here is an angle. That's nothing new. We all seen these angles, but we have to come up with names for things because we're mathematicians now, and we have to categorize and name all the things that we come across. So you'll notice that when I drew this angle, I started down here and I drew an arrow up to where it ends to denote this space in the middle. So we're going to call where I started the angle the initial side. And where the angle terminates, we're going to call the terminal side. In this way, we give some kind of direction to the angle. Since we have direction on the angle, I could say initial side, then go up to the terminal side. I could also set up an angle where we have an initial side and we go down towards the terminal side here. We have two different directions, so we have to call one of those directions positive. So the positive direction will be counterclockwise. Counterclockwise. And that leaves clockwise to be the negative direction. So counterclockwise is positive, clockwise is negative. So if I say draw a 30-degree angle, you start and you go counterclockwise 30 degrees. And if I say negative 30 degrees, you go clockwise 30 degrees. How's everybody so far? We're all okay. I just drew an angle. And it's like, oh, it starts here and ends here. And everybody's like, oh, yeah, we're okay. We got that. So let's talk about how we measure angles. We measure angles. One of the ways we measure angles is using degrees. One way to measure an angle is in degrees. This is supposed to be a D. I tried to fix it and I made it worse. So one way to measure angles is in degrees. And this is a good place to start because we're familiar with degrees. How many degrees is it if we go all the way around? You can just type your answer in the chat while I'm drawing. How many degrees is it to go all the way around? 360 degrees. So if we go all the way around, that's 360 degrees. That's a full circle. And then we just break this up into fractions. So some important fractions that we need to come up with. If we have an angle that just goes halfway around, how many degrees? I want to put that's where the angle is going to be, or the corner is going to be. If I go around a half circle, how many degrees is that? 180. So there's 180, and then we put a little circle as a superscript to say degrees. So a half circle is 180. This makes sense. A full circle is 360. Cut that in half, and we get a half circle. What about a quarter circle? How many degrees in a quarter circle? 90, because a quarter of 360 is 90. This one gets a special mention we have a 90-degree angle. What's another word for a 90-degree angle? It's a right angle. So we call this a right angle. And we have a special notation for that. We put a little box in the corner. And so that's our special notation for right angles. Any questions? How's everybody? Isn't it cool when on the first day we just kind of like start with stuff that we already know? That's always nice. So this is how we are measuring angles. Because this is a math class, sometimes the angles are just going to have generic names. We're not going to know values. Instead of using numbers, we're going to describe them with letters. So we got to come up with names for angles. So we usually name angles with lowercase Greek letters. This is because we're going to be making calculations. We're going to be making calculations with angles and lengths. And we want a way to distinguish the lengths from the angles. So if we use Greek letters, we're going to be talking about angles. And then if we use the other letters, we'll be talking about lengths. So we don't need to learn the entire Greek alphabet upper and lower. We just need to learn some common ones. So here are the common ones that I will use. If you start making a 0 and then kind of keep going and then cut through the middle, so up and around, this is a lowercase theta. I think in the UK they say theta, but I say theta. So there's a common one. Other common ones are if you make a kind of a short O and then draw a diagonal line through it, not quite an empty set symbol. Sometimes it's connected all the way through. Sometimes it looks like this. So it depends on how I'm writing at any given time. But it's kind of like a, we'll call that phi. That's a lowercase phi. So it's either one of these. This is kind of my lazy way of writing it because this comes out a little messy when I do it. So that's a phi or a phi. Other ones that I'll use are alpha. And then if we do kind of a rounded B, that's going to be a beta. And then the way I draw gamma is take an alpha and just kind of rotate it 90 degrees. So this is my written version of a gamma. I'll post this in the comments, and then people can, on YouTube, people will be commenting, the way you draw gamma is wrong. And I'll be like, oh, probably. And then I'll just leave it there. So these are the most, we don't need all of them. We just need some. Other ones that are important. Yeah, we'll just leave those because we don't use those for angles. That's more of a prefix. So theta, phi, alpha, beta, gamma. Practice drawing those. This is just to distinguish between angles. These are going to be angle names and lengths. So just to represent lengths, I'm just going to be using things like X, Y, Z, A, B, C. So these are the ones that we're familiar: X, Y, Z, or Z. A, the Fonzie letter. B. I don't think you need a pronunciation guide. I just want to find out who's going to be writing in their notes a pronunciation guide to the letters. Any questions? Comments? So, everybody got A, B, and C? Of course, because of course I like Fonzie, because Fonzie is cool. Until he tried to do that water ski thing. Does anybody even know who Fonzie is? All right. What's funny is that a lot of people don't know the show Happy Days, but a lot of people do know the meaning of the phrase jump the shark. Does everybody know what it means when a show jumps the shark? So that's like that's the point of the show after which the show is just bad. So I'm not sure exactly when The Simpsons jumped the shark, but at a certain point the show just started going downhill. And it has been for like 20 years. So I don't know if anybody even still watches The Simpsons, or if The Simpsons is just made because it's just kind of a societal habit that we have. And no one stops and says, hey, no one watches this show anymore. Why are we doing this? It's like, oh, because we must. All right. So we need to go over a couple of more common terms. If we have a couple of angles, let's say we have two angles that make up a right angle. Two angles that make a right angle. So if I have two angles, let's say an angle alpha and an angle beta, what do we call it when two angles add up to 90 degrees? Correct, these are complementary angles. These are also both acute angles, and they are complementary because they make a right angle. So two angles that make a right angle are called complementary. So alpha plus beta is equal to 90 degrees. The measures of the two angles is equal to 90 degrees. Alpha plus beta is 90 degrees. So we call those complementary angles. Anyone know what we're going to do next? Supplementary angles. Those are the two things that go together. Angles that make a straight angle are called supplementary. So if I have a couple of angles that add up to 180 degrees, say theta and phi. If angles add up to 180 degrees, then we say those angles are supplementary. Any questions? We're just going over terminology, so everybody's on board. We're just defining our terms. Angles that are less than 90 degrees, that's been brought up, are called acute angles. Angles that measure less than 90 degrees are called acute. What do we call angles that measure more than 90 degrees? Obtuse. Awesome. It's great in the math class. I love first day of math class because I only answer questions that everybody, I'm pretty sure that everybody or most people already know the answers. So, yes, I remember these things. We just kind of do a memory check on the first day. So we're just getting some terminology down. Angles that make up a right angle are called complementary. Angles that make up a straight angle are called supplementary. If an angle is less than 90 degrees, we call it an acute angle. And angles that are more than 90 degrees, we call them obtuse angles. Usually we mean, when we talk about acute, we wouldn't want like negative 450 degrees. We want to talk about inside. So this is alpha is some acute angle terminal with an initial and terminal side. If I went around the other direction, it would be more than 90 degrees. So I'm talking about this part, the smallest pointy bit we can make. So that's just one clarification. Also, when we talk about things like supplementary angles, we could have more than two angles to make supplementary angles. So if we have alpha, beta, and gamma all add up to 180 degrees, we would say alpha, beta, and gamma are supplementary. So we will often do that as well. Any questions? Comments? Right. Let's put these things together in to a triangle, the first kind of triangle that we want to study. Oh, actually, no. Let's pause the video here. Tomorrow, or Monday, we're going to start talking about right triangles. I just saw the time. So get started on the chapter 1 homework. We're just getting used to measuring angles, positive and negative angles. And then up next, we're going to start talking about right triangles. Here's the big thing that I want you to think about when we're talking about right triangles. We need some kind of connection between length and angle in a triangle. We know that a right triangle has, or a triangle just has 3 angles and 3 sides. And these values are all going to be related. So we're going to have A and a B and a C. And we're going to have angles, let's say angle alpha and angle beta. Let's give them names. So we need some kind of relationship between the side lengths and the angles in a triangle. That's what we need next. We need some kind of relationship, a relationship between the sides and the angles. We need something that connects the measures of the sides to the measures of the angles. Something that connects length and angle measure. So that'll be for next time. Our next meeting will be on Monday at 9:15. That's it for today. I'll see y'all on Monday, and thanks for playing.